Thanks everybody for coming. My name is Yufeng. Sorry about the technical difficulties earlier. Dead demos are sad. Networked demos are sadder without network. So unfortunately, it seems like there's a lack of data connection in the room. We're trying to get it fixed, but for now we'll go on and I'll hand wave through some of the things as needed. So basically, my name is Yufeng. As I said, I'm on Twitter at YufengG. And I'm a distance runner. I love to cook and build stuff. So I built something for you here. And this talk is kind of themed around Harry Potter. And so I had to add the obligatory fourth bullet. I know they say you only have 3 bullets, but. So does everybody know what Harry Potter is? Anybody need a refresher? Magical kids, school, dorms, boarding school? Yeah. So in the story, the kids, they live there, right? It's a boarding school, and the door to their dormitories, it's a painting. It looks kind of like this, and this painting talks, and that's how you get in. You give them a passphrase, right? You give her a passphrase, and let's see if I can get this video. So she's a little spunky sometimes, right? She wants to show off. And here she's going to try to break the glass. She really wants to make it happen. Amazing. And so Harry there is trying to say the password to her, right? Fortuna Major. And she's like, all right, fine. So I thought it would be fun to build a real world type of thing inspired by something like that. A door that is guarded by a painting. So let me turn this around for you guys so you can see what's actually going on. This is the part that would be a lot cooler if I had network connection. But basically what we have is a Raspberry Pi that's hooked up to a whole bunch of different items. I guess this didn't really pan out, no network, but I'll talk through some of it here. So we got the Pi hooked up to power, and then there's a little portable speaker here, this guy, so that it would be able to talk, right? That would be the voice of the painting or the door. Got a little webcam here to serve as visual and audio recording so they can hear. And then you would send things up to the cloud as needed to make things happen, and then upon authentication, you would unlock this little lock guy. So this is a close-up of the lock. It's just a deadbolt, a little servo motor, right? So this arm would just like swing this way, and this whole thing is jerry-rigged together with a little paper clip. Surprisingly effective, I will say. I'm very happy with how well the paperclip turned out. I thought about rubber bands, Bluetooth locks off the shelf. It turns out a lot of the Bluetooth locks they sell at Home Depot require you to have an app. And Raspberry Pis don't really support the iTunes App Store, unfortunately. So I had to go with something a little more hand-built. So this is the part where I would talk to it, and then it would think for a while. I had some witty phrases in here, and then this would unlock, right? Now, let's pretend that happened, right? The door unlocked, and just like that. And then you get access to the Gryffindor common room. Good stuff. And then I would ask you guys, does anybody actually want this system as for their front door? Or maybe the front door of their workplace? Anybody? Any no takers? No takers. All right. So yeah, a passphrase isn't really the most secure way to lock down your dormitory in your school or your house. And I always thought that was kind of absurd, right? Like Draco could be hiding around the corner over here, any Gryffindor, and then, great, now I have access to the Gryffindor common room. Good stuff. So let's make this better, right? And so how can we make this better? Let's add the visual piece. Right? We got a webcam here. May as well take a picture of your intruder at least, if they're going to be breaking in. So now I would say, it would go through the audio, and when you pass the audio portion of it, it would then say, great, you've passed this, now let's take a picture of you. So I would get in front of it, or have one of you guys come up here, and I set up the the pass image to be somebody smiling. I don't want angry people or sad people coming in. You got to be happy. And then it would see the smile, and then it would unlock, and all would be well. So it's a little better, but I'm going to guess that we're still not going to get any hands for this. Right? A word and a smile, it can open doors for you sometimes, right, if you're nice to people, but hopefully not your house. So this notion of using sound and images and things that are not just typing things into a keyboard is both old and new. Right? It's the most natural interface we know, but yet it's something that computers have not been really able to do until recently. And this conversion of taking sound and turning it into text, or taking raw pixels and deriving meaning out of it, it's not an easy problem to solve, or else we would have done this long ago. And just in general, right, the natural world it's tough to understand. And you can extend this further, right? Beyond sound and pictures, you could say meaning of what you're saying, the meaning of perhaps movement, right? You could wave your wand in a certain pattern, perhaps, and that would unlock the door. So how can we make that easier? How can we make the problem of breaking down raw images into meaning, or breaking down just audio waves into meaning easier, without having to go through the arduous process of something akin to machine learning, right? Feeding some system with just buckets and buckets of information to learn what is a smile generically, right? What does a human smiling generally look like? Right? That's something that we can't really encode by hand anymore. And so that's where this little abstract cloud I got going on here comes into play. So I want to talk to you guys today about two APIs that make these two problems easier: the conversion of text and the conversion of sound to text, and the conversion of pixels to meaning. So that's the speech API on the left and the vision API on the right. And I don't know why that red box came up again. So on the speech API side, as you might have guessed, it would turn audio into text. It's basically just dictation, right? You have that locally on your phone today, but as an API. And then similarly with vision API, you would go from a picture to some set of structured doc showing the meaning, and we'll dive into that as well. So on the speech side, it supports many, many languages, so that's great. If anybody speaks other languages, I will be picking on you, or calling on you, sorry. And it also supports both streaming and non-streaming, and filters inappropriate words, which I actually triggered once by accident because it misheard me, and it thought I said something bad, and so it said censored content, and then for some reason it said - Justin Bieber. Not sure why. And then on the before we go to the Vision API, this we can do a demo of because I have internet on the laptop. Hooray! Let's make this big and not long. All right, guys, say when it's big enough to read from the back. Awesome. All right, so I'm going to run the script, and I'm just going to record some sound to the laptop, and then it will send it up to the speech API, and it will just come down and just show what I said. Right? So not super kind of surprising or magical here, but hi, welcome to Code on the Beach. It's great to be here. So recorded. This particular script I wrote is recording using FLAC. It supports a couple of other formats, but FLAC is a nice, clean way to do it. And it also gives you back multiple other kinds of go down to the beach. That's been happening. Code on the beach is not a normal thing to say, and I guess it sometimes comes down to go down to the beach. And you can ask for more alternatives as well. But it gives you a confidence of how short it is, and then it gives you what it thinks it is. So usually you would just use that first transcript, but sometimes the alternatives can be funny, so I wanted to leave that in there. A question?
Yeah, can it break it down into the words and give you confidence per word as well? So you could actually try to automatically
Oh,
piece
it
the code
together.
on the beach now. Like, you know, that's already pretty good, right? So you go with that, and then you go through all of the alternatives in every word, maybe, to filter out the code, which might have a higher probability than down.
In that particular.
It just didn't make sense. But if you see that a couple of words actually are outliers, and you know they are much more likely to be in that sentence, what you said, but then the overall sentence wouldn't make sense for the API or something like that. Can you do that?
So currently the API doesn't expose. Oh, sorry. Repeating the question. The question was for the video recording, whether or not the API returns confidences for the individual words in the sentences, so that you can begin to piece together your own custom transcript through the different alternatives. Unfortunately, right now that's not possible. That's a really good piece of feedback, though. I like it a lot. It doesn't expose a lot of the innards. The idea of the API is to make something really simple for developers to use who don't, like, there was zero machine learning going on here, right? From my perspective. All I did was I made a JSON REST request, and I got a JSON object back, and I can move on with my life. I didn't need to deal with any sort of training, any sort of models. I didn't need to learn advanced math or statistics. I just got my text, and I can move on. So it works well in certain scenarios, and this is where I'll dive into that a bit more later, where you got to test it out, right? This is not a panacea. It's not a magical button you can push and now it unlocks the doors to everything. But for certain applications, it can save you a ton of legwork. I would like to try to record it again. I'll try to speak more clearly and we'll see how it goes. Hi, welcome to Code on the Beach. It's great to be here. I had a class in high school. It was one semester. It was called speech class, and I got picked on a lot for my enunciation, right? Wow. Yeah. So it really doesn't like code, apparently. So. Is it? Oh, it is. All right, there it is. So you have to know what to expect, though, right? That's the problem. You don't know what the user is going to say, and so to choose between the alternatives, like in this case, you heard me. So you know which word it should be. But if you had this as a web app and you were having your users say what they want to do, right? I want to go to the shopping cart. I want to add this to my cart or search for this thing. You don't know what they said. You don't have a person back there sitting inside your server saying, I heard them. Now I know what they really want. So that's, in a nutshell, the speech API. Let me move this around. Like I said, it's meant to be straightforward and simple, right? You send up the audio and you're pretty much done. So with the Vision API, in large part is the same idea. There's a little more to the response, but the request is the same exact thing. You take a picture and you send it up. But when you send it up, you can ask for a little more detail in terms of the response. You can express a little more intent about what it is you're looking for in that picture, what category of item. Specifically, there are these 6, and there is a 7th kind of asterisk footnote one as well. So label is talking about what do I see in the picture. Label this picture for me. This is a picture of an audience or a conference, right? Or you might have a picture of a computer or technology, etc. Landmark is something that lets you basically pick out where this picture was taken. And that's going to be somewhat hit and miss, right? If you have a picture of like the background of your living room wall, it probably doesn't know that it's your house. It's not using the geotag at all. It's just using the pixels, the raw pixels. But if you have a picture of the Eiffel Tower, on the other hand, it will be able to tell you that and give you latitude and longitude. Logo detection looks at logos on various things, and that's also currently somewhat limited in terms of which logos will work. So again, testing is your friend. Facial detection is a lot of fun. It is pretty rich in terms of the data that comes back. It does not recognize specific faces, but rather generic facial features. Are you smiling? Are you sad? Where is your nose? Where are your eyes? Which way are you facing, right? In terms of your 3 axial, like which way is your face pointed in relative to the picture. Are you wearing a hat? I did a Donald Trump one once, and it gave headwear likelihood of possible. So just saying. Text is just straight up OCR. You got a document, you got a t-shirt with words on it. That's all gonna turn it into text for you. It'll put polygon bounding box, X, Y coordinates. You can identify where text is and get the raw text out. And then Safe Search goes through explicit images, medical images, violent images, and spoofs. So if you have a painting of the Mona Lisa, but someone photoshopped the face to be some other face, it might flag that as, a spoof. So going into the responses of some of these, with label detection, here we have a beignet. It's like a fried dough thing with powdered sugar on top. It's pretty tasty. And you see it comes back, just like with the speech API, some multiple guesses as to what it might be with multiple scores, descending order ranked. And you can specify, again, how many you want. Do you want 5? Do you want 15? Do you just want the top one? You don't care what the alternatives are. Just whatever Vision API thought was the best guess, we'll go with that. And landmark detection, this is to go with the theme, the Wizarding World of Harry Potter, down here in Florida. And you see there's a latitude and longitude. And if astute observers might have noticed, there's also this mid object with some random garbles. And that's basically an ID. It's an opaque string that corresponds to the knowledge graph and will let you kind of dive deeper into what that entity, quote unquote, or label that it found, that location. And you saw that both in landmark as well as in label detection on each of these. So basically, it's kind of a detail on that particular kind of word and what it means as a concept. And within that response, when you go to the knowledge graph, there's also a link to Wikipedia, so you could theoretically then continue down that rabbit hole and scrape the Wikipedia page and get even more content out of that. And so this is a separate, not part of the Vision API, this is a separate API that I just wanted to call out as this also exists. Face detection. So this is me with a water bottle in my room, and it gets my face, and I actually have this picture on my laptop right now. We'll go through it, and you'll see that it also picks up that Deer Park water bottle logo, which I was not intending on having happen. It was just me holding up a water bottle, and I happened to point it in the right direction that the logo lined up. But the other kind of pieces in the response, I mentioned earlier the way the face is facing, right? You get the roll angle, and it's in here kind of scattered around. I wish they would put it together. You got pan angle here and tilt angle. So those correspond kind of the 3 directional axes that your face can be pointing. And then you have joy, you have likelihood, and like sorrow likelihood, et cetera, et cetera. And there's, this object is huge, so I kind of blanked out a bunch of the extra stuff. All right, let's take a look at it in action. This one. So the picture is the picture you saw, and the response, I'm just going to type it to less because it's really long. So this is a long JSON object that you can parse through kind of at your leisure. And so this is firstly is the face annotation. So this is all the pieces about face. You got blurred likelihood, anger, and then the bounding poly describes the box that my face was in within the picture using the pixels, like the pixel values of the image itself. So it's pretty straightforward if you want to draw a box on top of me. And then there's a detection confidence. Then the whole long list of landmarks. So all these different positions on your eye, on your ears. And so this is kind of beyond my needs, but you can really get detail. You see there's a midpoint between the eyes. Right? It's not just a dot for your eyes, a dot for your other eye, and a smiley. Yeah, you can draw a smiley face on them, but like you got midpoints, you got not just the nose, but the nose tip. And then you got upper lip and lower lip. So you can, and then somewhere, one of the terms in here that I don't remember the exact thing is, but it's that spot between your nose and your mouth, the mustache mark. So you can overlay mustaches as you please. So continue on down. We're going to go past a ton more of these face points. Yeah, like chin, gnathion, like what is that supposed to be? And there's also sorrow and surprise, and a little more photograph information. So labels. These are what the Vision API thought that this picture was, in general, quote unquote, right? It's kind of a picture with a lot of pieces going on. You might describe it as selfie. You might describe it as, hotel room. You might describe it as someone drinking a bottle of water. So it happened to pick out a couple of things. We got person, you got a t-shirt, glasses. It's not a bad thing to point out. And then the logo annotation. So you got the box around the logo, and then a description, along with this mid ID, so that you can then see what is this logo that I found. So that's down below in the bottom here. Highlight it. Yeah. Text annotations. So this is basically a box around the text that it found in the picture. So most of the words are in the water bottle, right? So it found the deer, and then kind of the park, but it was a little mangled. And then what it does is it takes that text and splits it onto separate word-by-word boxes. So it draws a box around each individual word then. So it really goes on and on and on. So it's a big object. Take what you need from it, dump the rest, right? Let's just space bar through it, and then this is the full thing. All right. So yeah, found deer, and then some other words. All right, onwards. So as we saw with the Vision API, it's pretty good at picking out very detailed things, right? You saw it picked out the words. It can pick out numbers, right? When it's zoomed up and it's clear, and you can tell what is a picture of, like just in general. No, this is a picture of a tractor. No, this is a picture of a dishwasher, and so on and so forth. And I want to contrast that with something like this, right? A more general picture, perhaps closer to what you might take a picture of in real life. Right? I took a picture of this random thing, this podium here, or like take a picture of my computer. And so if they're zoomed in, it's clear it's a computer. But if it's like a more general picture like this, and you're saying, Vision API, find me the Statue of Liberty. I'm really hoping that it's the Statue of Liberty in this picture, but I don't know. Here's some pixels, right? It's probably not going to say this is the Statue of Liberty, because it's hidden off in some logo of a sign. It's just going to look at this whole picture and say, well, this in general looks to be the picture of a sidewalk or the picture of a storefront, right? And so this is where some of those limitations I was talking about earlier comes in, right? If you're trying to make something very specific that searches for just flowers or just bumblebees, then this may not be exactly what you're looking for unless you're willing to really start slicing and dicing the picture into multiple sub-pictures, which is one approach that we've seen people take in getting around this kind of big picture phenomenon. So sometimes people ask me about the speech API and say okay, the speech API is well and good, right? You took audio, you turned it into text. So now I have a bunch of text. My computer doesn't really know what text means either, right? They're just letters. It's just ASCII characters. If the user happened to say something that I can just do a naive string match with, then okay, I know the person wanted to add to cart. Great, I can go do that now, right? The user wanted to search for something, right? Like you think about how Siri might work, right? You say or Xbox, okay Google or Xbox, do this. You have to start it with a key phrase. It hears Xbox, it turns it into a word. It says, yes, I know what this word means, and now I will listen to your instructions. But then those instructions can be a little bit more unstructured. And so if we want to add some meaning to these words, consider the natural language API, right? Natural language processing classically has been the field that studies words and their meaning in terms of syntax and such. And so there's three chunks to this. Entities, and this is kind of a recurring theme now, this entity thing, right? We see entities in the speech, we saw entities in the image API, and now we're seeing entities again in the natural language API. And so it'll pick out salient things inside a sentence, right? And then the second method is sentiment analysis. How positive or negative is a sentence? And, is the sentence positive, negative, or neutral? And then how positive or how negative, right? Magnitude and polarity. And then syntax, this is the kind of classic NLP or natural language processing problem of identifying the verb, the subject, the object of the verb, all the things we tried to learn in grammar school, but really forgot every summer and then had to relearn during the following school year. So entities, boom, you pick out the things, and this is useful because sometimes when I first saw this, I was kind of well, what if I just picked out the capitalized words, right? I'd be done. I don't need this API. But then there are definitely entities that are not capitalized, and there are things that are capitalized that are not entities. And so it's not always easy to match up what it is. And the response from these include those mid-IDs again, right? So then you get Wikipedia links that you can scrape further. You get just more detailed information about it. And this particular set of responses from natural language also gives a type. Is it a location? Is it a person? Is it an event? And so on and so forth. And so that can also, and you can kind of see it if you look carefully, like this is person, up here is organization, and the one on the far left is location. And so that kind of information can be valuable in beginning to understand what is happening in a sentence. And this is before we've even parsed out the grammar. With sentiment, it's pretty much what you would expect. It's a pretty simple response. You get polarity and magnitude, right? Positive, negative for polarity, 1, -1, or 0, and then magnitude is 0 and up, up and up and up. And then syntax, so the sentence about poutine, and you get this huge tree, right? This is a long sentence. I would imagine you would want to start with a smaller one to start with, but it's got all the parts of speech. Conjunction, junction, what's your function, right? And so this is my favorite slide because all 3 APIs we talked about, vision, speech, and natural language, have free tiers. So you don't need to sign up. You don't need a credit card. You can just go and use them. Try them out. Play around with them. Have fun. Take a picture of a document, then run it through natural language API. Say something, run it through natural language API. Get an understanding of which of these pictures has a person in it. Which of these pictures has a smiling person in it? Who's of all this text that I have, which sentences are the most positive? Which sentences are the most negative? Things like that. Call center logs are another kind of quote unquote more practical use case, business cases. But yeah, this is free tiers, and that is the gist of it. I'm sorry that we couldn't get this to work. I will continue fiddling with it in the remaining time, but in terms of content, this is what I prepared. Questions? Yes?
So I'm just wondering, for your use case there, the idea was to detect you in the picture and then open the door, right? The vision part?
So the question is whether or not it detects me in the picture, right? So I wanted it to get the passphrase and then just a picture of someone smiling. It doesn't have to be me. So it found joy likelihood, likely or very likely. The Vision API recognizes what a face is. It doesn't recognize a specific face. That's the best way I can think of putting it. So you can't say, only unlock on my face, because privacy, basically, in short.
You built that on top, right? Like for instance, I don't know how many features it has. You showed a lot
Yeah,
of features.
there's
right?
a lot
I
of
could
things.
Just, maybe even without training my own code, but I could just actually go and say if those 50 features of my face are close enough, then that assume it's me.
Absolutely,
right?
absolutely. That's a really great use of that in terms of taking what we got and kind of finding a creative use on top of it. And to repeat it for the video, the question was about using the data that came back from the Vision API and just basically doing a raw kind of fuzzy match against historical data, and basically you've created your own you're running machine learning on top of the Vision API, which is machine learning. So we're just doing machine learning loops over and over again. And so that's a great use case. A lot of times the limitations of the API kind of show up, but then you kind of can go past them, right? You can say, okay, I have these limitations and constraints, right? This is all I've got. This is the JSON object I've got to work with, but I can do something interesting with them nonetheless, because it took so little work to do the request. So now I have so much more time and energy to do something fun with them. Rather than spending all this time learning about machine learning models, I can figure out what I want to build and say, oh, it'd be nice if I knew what was in this picture. 2 years ago, that would have been kind of like, low priority, we'll just move on. We'll just store the picture and call it a day. But now you can say, oh, let me just figure out what's in there, and maybe we can do something interesting with that, right? And so this idea of using these as Lego bricks, small Lego bricks in your big building, and not having to manufacture these Lego bricks out of platinum. You can just take one off the shelf and put it on there, and you're good to go. And you move on with your life, right? Yeah. Other questions?
So for the natural language, you said you get on the free tier was 5,000 units. What exactly constitutes a unit? And then what is the pricing past the
Yes. So the question is around the natural language API units and pricing. So 1 unit is 1,000 Unicode characters. This is just to prevent you from making a request with like just a huge blob of text, right? And so if you can do that, it'll just count every 1,000 as 1 unit. And so 5,000 units a month. All right, let's see if I remember this. So I'm not a sales guy, and so I don't remember all the pricing. I wanted to highlight the free tier in particular because can let you guys get hands-on right away. In general, it's cheap. I can't remember the natural language. Let me just pull it up for you. Yeah, I have it here, so we may as well look at it. It's just tiny because this projector is the highest resolution projector I've ever seen. This is not 640 by, all right. So $1 per 1,000 past the first 5,000, up to the first million, and then goes down from there. So the numbers are per 1,000 units, and then these are the ranges for kind of the prices. So if you want to do 6,000 units, it would cost you $1. Yeah. And then speech API, because I have a feeling that might come next, is I did the math on this. It's kind of weird, right? It's this little bit per 15 seconds. But you do the backwards math, you get 41 minutes of audio per $1. And so the audio I was sending up was a 5-second clip of the sentence I was saying. And of course, the first hour is free. So I could record this entire talk and turn it into captions, right? And of course, I would really just upload it to YouTube and have YouTube do it for me for free. But that's if you have your own video system, you could do that. And then Vision API, I want to say, is on the order of. See, it's priced a little more granularly. Oh, come on. All right, it's per 1,000, and it's by type. So if you make a request that asks for facial recognition, labels, and landmark, that counts as 3 kind of each of these, right? And so, and you only get, it's not 1,000 for each of them, right? It's just like 1,000 total for the free tier, I believe. Though this chart is kind of misleading in that sense. So it might be actually 1,000 for each of them, which would be awesome. And the pricing is per 1,000 pictures. So depending on how much you want to understand your home album and how big your home photo gallery is, this may or may not be an attractive route to take. So yeah, they're all just REST APIs. We have client libraries in a number of languages, but if you really want to make a request with Haskell, I'm sure you could figure out how to make a web request with Haskell, and then you're set. Right? As long as you can make a REST API call, you're good to go. You can invent your own language and do it. You can do it with Rust. You can do it with, what was the other one? Kotlin, I saw recently, right? The other JVM language that just came out. Yeah, it's good stuff. And so yeah, just play around with it. There are, of course, other machine learning APIs out there, and they all have their strengths and weaknesses. They all have free tiers, so play around with them, see which ones work well for you. Other questions? All right. That's been good. Thanks so much for coming. This was fun.